I'm Alessandro Vespignani. I'm affiliated at Indiana University, USA, and the Institute for Scientific Interchange Foundation in Turin, Italy, and I'm a physicist. If you think about natural sciences, the main things was data. So this is what allows us to progress in a way, that now allow us to break the atoms and create materials. Well, if you think about social system, techno-social system infrastructure, well, the limit was data. And now, for the first time in the history of humankind, we can, gather data on social behavior, individuals' behavior, the interaction of humans with infrastructures, with biological systems in a completely unprecedented way. These open unprecedented opportunities to study those systems and create a new science that is really able to, understand and manage complex socio-technical systems. And this is, I think, is exciting as the turning point from classical mechanics to quantum mechanics. Is really, we can't even completely assess what opportunities will be open in the future. Well, the first thing that comes to my mind is global health. Global health means can we predict the spreading of the next pandemic pathogen? Can we understand if an HIV mass vaccination campaign will be effective or not? Can we understand, according to the migration pattern of people, if we will have a resurgence of TBC? What is the effect of antibiotics in intensive farming? Those are problems that really contains a systemic risk to our society. A global health crisis could reverberate on the economical system and create an immense danger for humanity. But as well, we are at the edge of finally getting answers, and we want to have quantitative answers on those systems, and I think these are one of the most pressing challenges for me. So we were able to send a man on the moon, but if I ask you how we people connect together, how we commute to our places, if we have a global world map for that, we don't have. And if you want to predict the spreading of a disease, you need to know what is the human behavior. Now finally, and this is the big vision of FuturICT, ICT and technology allow us to have this nervous system around the world that put us in the position to get data in real time that will allow to process models in real time and finally get answers on those systems, describe, control, and optimize the behavior of systems. We need a quantum leap. When you're talking about global health, you're talking about 6 billion people. When you are talking about economics, you are talking about millions of people trading at the same moment. You need really to take advantage of the ICT nervous system we are building to create a different perception of what's happening to the system. And then, FuturICT somehow has the vision to build not just the nervous system that is developing by itself because of technology, but a way to process that amount of information and to create a cognitive power for the society as a system. So that as we get, visual inputs or sensory input in a body, then you act upon what you get. The same is for society. You get all these inputs from a nervous system, from the social nervous system, and then you act upon it because you are able to process those data. My dream is to build, the analogous of a weather forecast infrastructure in the area of global health and diseases. So really to have the possibility of real-time data gathering about diseases, people mobility, immigration, whatever it's important for a disease, also climate changes, and fuse those data in models, have many models as in weather forecast, and then create statistical prediction of what will be the outcome in the future that are continuously corrected with the input from new data. So that basically you have an endless cycle of refinement of your models, so that you get, better and better simulation for the next week, the next 2 weeks, the next 1 year, depending on what is the problem you're looking at. If you want to do weather forecasts, you need to understand what is turbulence, what is the basic law describing the gas and fluid masses. Well, the same we have to do for society. We have to get a better description and theoretical understanding of the society, and that's another big challenge. And then, for sure, we are going into an age in which petabyte data scale, petabyte computing will be necessary. And this, of course, is a challenge in terms also of hardware and infrastructure. What we can do to really simulate the behavior of 6 billion individuals in a real time. So, well, that's a huge infrastructure that we need to have. I can imagine that my models will tell, the number of people that will be affected by the disease is going to approach a social disruption point. What we can do to prepare ourselves to that point. Or in other cases, since it will be milder, we can just say, well, the disease will affect those people in those areas with those timing. And have control of the system. You need to have anticipatory power. That's what you want. You want to have the time to react.